Hello, and welcome back to this penultimate commentary for this course in STEM education. When we talk about STEM education in high school technology education classrooms, we are not simply talking about adding more science or mathematics content into shop spaces. We are talking about designing learning environments where students can read, write, calculate, communicate, design, test, revise, and justify ideas in ways that reflect how knowledge is actually created and used in the world beyond school. For tech studies teachers, this work sits at the intersection of hands-on making, problem solving, and critical thinking. And it requires us to think carefully about how learning is made visible, especially through assessment. So let's begin by framing these thoughts with the relevant learning outcomes for this particular thematic section of the course. Here, we might begin with the first learning outcome, applying STEM approaches to developing literacy, numeracy, digital literacies, and student contributions to knowledge. In Ontario Tech Studies classrooms, literacy and numeracy are already embedded in daily practice. Whether students are interpreting technical drawings, calculating tolerances, reading safety documentation, or writing project rationales. A STEM approach asks us to make these practices explicit, intentional, and accessible. For example, when students design and build a prototype, they are engaging in disciplinary literacy. They read schematics, interpret data, and communicate technical decisions using domain-specific language. Numeracy appears when they calculate measurements, analyze performance data, or justify design trade-offs. Digital literacies emerge when students use CAD software, simulations, or collaborative platforms to document and refine their work. Importantly, STEM learning positions students not just as consumers of information, but as contributors to knowledge. When students document their design iterations, reflect on failures, and share solutions with peers, they are producing evidence of learning that goes far beyond a final product. These artifacts, the design journals, process videos, annotated schematics, become powerful assessment evidence. As Missler argues, the author of next week's text we will be reading, effective STEM assessment must focus on what students can do with their learning, not just what they can recall. In tech studies, this means valuing process, reasoning, and iteration alongside technical accuracy. Moving on, we will find that the second learning outcome focuses on developing interpersonal and interdisciplinary communication skills. STEM learning in tech studies is rarely solitary. Students work in teams, negotiate roles, explain ideas, and integrate perspectives from science, mathematics, engineering, and technology. These interactions are not secondary. They are central to learning. A STEM approach encourages teachers to design tasks where communication is required for success. For instance, students might need to justify material choices using scientific principles, explain mathematical models to peers, or present design solutions to an authentic audience. These moments create opportunities to assess communication as a learning outcome, not just a byproduct of group work. Research consistently shows that assessment in STEM classrooms often privileges monodisciplinary knowledge while overlooking interdisciplinary practices such as collaboration and communication. Tech studies teachers are therefore uniquely positioned to address a gap by using tools like rubrics, peer assessment, and reflective checkpoints that make communication visible and valued. When students engage in structured peer feedback, design critiques, or collaborative planning sessions, teachers gain insight into how students listen, respond, and adapt ideas. These skills align directly with Ontario curriculum expectations related to teamwork, critical thinking, and problem solving, and they deserve explicit assessment. Now, the third learning outcome asks that you create assessment and evaluation strategies that provide equitable opportunities for students to demonstrate critical engagement with concepts, skills, and content. Here, equity in assessment does not mean lowering expectations. It means recognizing that students demonstrate understanding in different ways and that assessment systems should reflect the complexity of STEM learning. Mistler highlights that traditional assessment methods often struggle to capture interdisciplinary and authentic learning, particularly in STEM contexts. In response, research strongly supports the use of authentic, formative, and alternative assessments, such as portfolios, performance tasks, and reflective documentation. In a tech studies classroom, this might look like assessing a student's design process through a portfolio rather than a single test, or allowing students to explain their reasoning through oral presentations, videos, or annotated models. These approaches reduce barriers for learners while maintaining rigorous expectations. Equitable assessment also requires alignment. Learning goals, instruction, and assessment must work together. If we expect students to think critically, collaborate effectively, and apply interdisciplinary knowledge, then our assessments must be designed to capture those outcomes. As Mistler emphasizes, assessment is most effective when it is integrated into instruction and used to inform teaching decisions in real time. For tech studies teachers, formative assessment, check-ins, design reviews, reflective prompts allows students to receive timely feedback and adjust their learning. It also supports teacher responsiveness, ensuring that instruction evolves based on student needs. To end this commentary, if we take all these ideas together, these three learning outcomes point to a vision of STEM education in tech studies that is authentic, inclusive, and deeply connected to practice. STEM approaches strengthen literacy and numeracy by embedding them in meaningful contexts. They develop communication skills by making collaboration and explanation central to learning. And they support equity by valuing diverse ways of knowing and demonstrating understanding. As future tech studies educators, your role is not simply to assess what students build, but to assess how they think, communicate, and learn through the process of building. When assessment is designed thoughtfully, it becomes a powerful tool, not just for measuring learning, but for advancing it.